Yes, so I was saying we have covered the basics of surface area, and now we are looking at more complex surface area problems. So in today's lesson, we're going to work on figuring out how to only, or rather, how to do more complex problems only on surface area. Okay. So let's get started. In order for us to do this, I want to hear what you guys have to say. Yes, Umar.
Ma'am, do we have to like split the rectangle in half, calculate the surface area of one, and then calculate the surface area of the other, and then we must add it together?
Not really. What you will have to do though is like for this shape over here, which is an L, you'll just have to split the L into two so that you can calculate. Remember, surface area, it's just the area of each face added together. So if you split them, Umar, into two rectangular prisms, do you see that you're going to take the face, you're going to include this face in this rectangle? That's actually not part of the surface area of this shape as a whole. Umar?
Yes, ma'am, I see it.
Okay, so we're not really going to split the shape for surface area. What we are going to do is we're just going to calculate the area of each shape individually, or each face individually. And then when we get to faces where there is like an L, that's where we break up the shape, as in the face, the shape that is the face. We're not breaking up the entire object. We're just breaking up the shape that makes up this face into two so that we can calculate the area of that face. Does that make sense? Great. Let us now go ahead and actually do that. So Uma, I don't know if you wanted to help me answer, but if you did, you are welcome to help. But let me go back to this principle that we spoke about last week. Whenever you see rectangles, immediately I want you to know rectangles mean opposite sides are equal. So immediately this side is 4, this side is 12. Why? Because this is a rectangle. Do you guys see that? Use some your reactions. Let me know. There you go. Sorry, I'm trying to figure out the best way to do this. This is clearly not the best way. Yes, okay. Picture. I don't know. There's a new way I'm trying to open up the chat. So sorry. I'm just literally trying to figure out how it works, but it's very hard to keep up. If I miss a message in the chat, just like send another message or talk and then I'll get to you. Anyways, so I saw the thumbs ups that we saw. Okay, this is 12. Now, I want you guys to tell me what is going to be the length of this side over here.
Ma'am, it's gonna be 12, sorry. 12.
There you go. It's going to be 12. 100% it's going to be 12. And I see Tyra and Unati. Yes, 100% it's going to be 12. Why? Because this is also a rectangle. Okay, now I have this rectangle up here where they've given me a measurement. I want you guys to tell me, what is this line going to be? 100%. It's going to be 5. What is this line going to be? 12. Beautiful. I'm doing this from the beginning because I know when we actually start doing it and we, we like start to pull it, like if we have to figure out the length of this line and I say 12, you guys are like, but ma'am, how? Well, literally, I pulled it from 12 up here. That means this is 12. That means this is 12. That means this is 12, which also means that this last bit here is also, oh, and I don't know why I erased everything. It means that my last line over here is also going to be 12. What is the length of this line going to be? 100%. What is the length of this line going to be? Not 12. It is going to be 9. I want you guys to tell me, how did you get 9? 5 plus 4, right? Where did we get 5 plus 4 from? Well, this line must equal to this line plus this line. And if you look here, this is a rectangle, which means this line is 4, which means when I add this line and this line, it should be 9. Okay, if this line is 9, it means that this line is 9 because of my rectangle. So it's just really a whole lot of pulling equal sides from measurements that you've been given. Liaho, I am sorry to hear that. Maybe rejoin, and that'll help. Okay, so now that we've done that, let's go and number my faces. So I'm going to number this 1, 2, 3, 4. This one will be 5. But now, what faces am I missing? Where am I missing? I'm missing my face underneath. So my face at the bottom will be number 6. I'm also missing my face at the back. So that will be number 7. And I'm also missing the face on the side over here. So that will be face number 8. So we literally have to calculate the area of 8 faces, add them together, and that will give me the surface area. So what I'm about to do is going to be confusing for you guys, because I'm going to do it all in one step. Well, actually, it shouldn't be confusing. So let's look. What I'm going to do is I am Itandile and Imise. If you guys could please focus right now, that would be great. Because I'm busy reading things about dermatology and I'm just getting very distracted. So let's go and let us go and put this. So we're doing surface area, okay? So total surface area, and you'll see sometimes the abbreviation is used as TSA. Yes, immediately.
Ma'am, may I please give the formula for surface area?
For sure, you can.
It is, wait, where now? Oh, it is, sum of area of all faces.
100%. So it's the sum of the area of all of my faces. 100%. So what we are going to do is we're literally going to find the area of each face and then add them together. But I'm going to do all of it in one step. So just work with me, you guys. We're starting with face number 1. It's all rectangles. So to calculate the area, it's all going to be length times breadth. So face number 1, I've numbered it on the diagram. It's going to be 12 times 3. That's the area of face number 1. Plus area of face number 2 is going to be 5 times 12. Plus the area of face number 3 is going to be 12 times. And somebody tell me, how do we figure out the length of this line? What is the length of this line? Also, I can't see if anybody's hands are raised. So, if there are hands raised, just no, I can't see. 100%. I'm so glad to see answers in the chat that are saying 7. It's going to be 7. If you look at what's happening, it is literally, if this line is 10, and where's this? If this line over here is 10 and this line is 3, then that means this whole line must be 10. And if this is 3, then that means the small one must be 7. If I'm going too fast for you, please do stop me. I am just going a little bit fast because we are doing the complex problems. So yeah, that's that. Okay. So moving on. Oh, Emilia, I see you asking how is it 7? Did that make sense to you what I just did? Or do you want me to re-explain that?
May you please re-explain, ma'am?
Okay. So do you see, Emilia, that this line over here is 10?
Yes, ma'am.
Okay. So do you agree that this line that I've now just highlighted would also be 10?
Yes, ma'am, because the opposite sides of a rectangle are equal.
100%. Do you see that this side is 3?
Yes, ma'am.
So do you agree that this part of the line here would be 3?
Yes, ma'am, because opposite sides.
100%. So if I know that part is 3, so this part
Then
over
you would
here is 3.
say,
Mm-hmm.
so then you would say 10 minus 3, which equals
100%.
7.
100%.
Oh, okay, I understand. Okay.
Glad to hear it. So we have...
Thank you, ma'am.
Pleasure. So we have... I'm just going to write this out again, but smaller. So we had 12 times 3 plus 12 times 5 plus face number 3, we now know this is 7. So it's going to be 12 times 7 plus face number 4 is going to be 12 times 4 plus face number 5. Face number 5 we have to break up into 2 parts because if you look at face number 5, I can't calculate this by itself. It's 2 rectangles. So I have to break it up. You could break it up either which way. You could break it up like that, or you could break it up like this. I think I'm going to go with this because it's just easy. I already know this side is 4, which means this side is going to be 4. I also know this side is 7. I know the bottom part here is 3, and I know the opposite part here is 9. So face number 5, we've now broken it up into 2 parts. It's going to be 3 times 9, which is this section over here, plus 4 times 7, which is this section over there. Did we all follow how I did that? Okay. I'm seeing thumbs ups. If you guys are lost, sorry, I dropped my pen. If you guys are lost, stop me, stop me, stop me, stop me. Moving on. Yes, Itandile.
Good evening, ma'am. Ma'am, why did you split it? Is it because there's 2 rectangles or is it because you wanted to?
It's because there's 2 rectangles. Even if I didn't want to, I there was nowhere else. There was nothing else I could do because this is an L. Do you see that?
Yes, ma'am.
So do we know how to calculate the area of an L?
No, ma'am.
We don't, right? So I had to break it up so that I could actually calculate the area of that face.
Yes, ma'am.
So that was for face number 5 over here that I just did. So I just wanna, this was face number 1. This was face number 2. This was face number 3. This was face number 4. And both of these are for face number 5. Now I'm gonna move up a little bit. And I'm going to move this a little bit that way, just so I can have some space. So we on face number 5. Let's look at number 6. Number 6 is the bottom face, the face that's at the bottom. I hope you guys can see that that would be 10 times 12. 100%, Uma. When we're looking at face number 7, face number 7, do you guys agree? No, not, oh wait, face number 7 is this one over here. So that would be the face at the back. So that would be 9 times 12, 100%, Uma. 9 times 12. Okay. So this would be 9 times 12. And then face number 7, well, this is what I wanted to tell you guys. Do you guys agree with me that face number 7, this face over here at the back, do you agree that this face would be the same as face number 5? So what I'm actually going to do is I'm actually going to just do this. I'm gonna move that up a little bit, move this up a little bit, and then move this up a little bit. And what I'm going to do is I'm actually going to say, well, face number 5 is going to be the same thing as face number 8. So I'm actually going to multiply that by 2. So now this over here is actually us adding face number 5 and face number 8. This one was 6. This one was 7. Okay, very long sum, as you can see. I hope that you understood it. If you didn't multiply, it was fine. The only reason I did multiply is because I didn't have space. I didn't have space to go and say plus 3 times 9 plus 4 times 7 again. So I just multiplied by 2. It was just easier for me that way. Itandile, was that your question?
No, ma'am.
Mm-hmm.
Are the numbers the same at the back? At the other side, number 8?
Yes. They would be the same. If you look at it, it would be 7 times 4. Look here, Itandile. At the back, there
Yes,
would
ma'am.
be the 7 times 4. And there would be this 3 multiplied by right down to the bottom. Think about this. It goes right down to the bottom at the back. And that is 9. Do you see that?
Yes, ma'am.
So see, 3 times 9 and 4
Yes,
times 7. Exactly
Yes.
what was face number 5.
Yes, ma'am. Thank you.
Okay. Now let us add everything up. 12 times 3. Let's see. Quick maths in the chat, please. Uma was so quick. 36. Liaho came second. Who's third place? I mean, I know we've seen the answer already, but anybody for third place? Shady. There we go. 36. Okay. Place number 2. What is that? I knew you guys would be waiting. Quick maths. 60. Number 3. Quick maths again. 12 times 7. Ooh, immediately. This, wow, how many different answers did we get? Oh no, 60 was for the previous one. I see immediately Bree and Leah who are, I don't know how you guys got the same wrong answer, but that just makes me think we're copying. Well, except you, immediately. 7 times 12 is in fact 84. 10 times 7 is already 70. And then 2 times 7 is 14. Add the 2, you get 84. Yeah, I'm watching you now. 12 times 4, what are we getting? Masungolo was first, nice. Shady Uma 48. Liako, our copycat.
Ma'am, I'm not a copycat, ma'am. It's just that not everyone is faster. That's why, and I'm a bit slow.
No, but Liako, how did you get the same answer as Emise?
Okay, ma'am. Okay, ma'am. Yes, ma'am. Yes, ma'am. You did catch me. You did catch me on that one. But the others, ma'am, the others was definitely me.
Okay. I believe you. I believe you. We then have 2 times 3 times 9. What are we getting there? 2 times 3 times 9. There we go. It is 54. Tyra, just check your answer. Try again. 2 times 3 times 9. You should be getting 54. Did the whole thing added? Oh, Uma, I didn't even see your answer actually. 110. Oh, okay. Makes sense. So 2 times 4 times 7. What are we getting there? 56. Yep, that is correct. No. 56. And I'm going to finish up the last two. 10 times 12 is 120. Thank you, guys. And 9 times 12 is 108. There you go. Now, somebody add this up. Let's see now who has quick math skills. Uh, 566. That looks like Itandile. And 566 what? Centimeters cubed, squared, normal centimeters? What are we doing here? Units squared. You almost had me fooled, Uma. I was like units. And then you added the squared, you saved yourself. So Intle, it
Ma'am, you
is.
put cubed. You didn't put squared.
Are you sure that's a 2?
Sorry, ma'am, I can't see. Sorry.
I was like, cool, that's okay. It's a new name. 566 chickens. Unfortunately not. It's just centimeters squared. So that's that. So this was quite a long thingy mabobby. Quite a long question, but not difficult. It was just long. It wasn't difficult. Let me know, use your reactions. How did we feel about this? Do we feel like, okay, this is actually not so bad? Is there a short method? Not really. Not for these types of shapes, Tyra. For these types of shapes, you literally have to calculate the surface, not the surface area, but just the area of every single face and then add them up together. I did hear a hand thingy-mabobby, yeah. I did hear a hand, yes, Emise.
Ma'am, so you see for the face number 5 plus 8, 5 and 8, ma'am.
Yeah.
Maybe explain how you did why you multiplied it by 2.
Okay. So immediately I didn't have to multiply by 2. I could have just moved my screen, but I didn't want to move my screen because then half of the block was going to be out. I could have, let's show you. What I could have done is, remember this was what it was like when it was just 5. So I could have gone for face number 8. I could have said 3 times 9 again. And I could have plus 4 times 7 again. Because if you look at face 8, do you see that what would have been at the back would have been a square over here, or rather a rectangle, and that rectangle would have been 4 times 7.
Yes, ma'am.
So I added in there the 4 times 7, and then the other rectangle at the back would have been the 3 on the top here multiplied by this line going all the way down to the bottom, which would have been equal to 9.
9.
Do you see that?
Yes, ma'am.
So I could have added it at the back over here, like what I just did now, but I just didn't want to move my screen. So a shorter way, anyways, if you don't want to do this, is, do you see this is 3 times 9? So it's in brackets, it's plus 3 times 9 plus 3 times 9. So think of this as a variable. Think of your bracket as a variable. It's like terms, we added them. So that is just 2 times 3 times 9, and then I can remove that. If this was plus x, like terms, add them together, plus 2x, which is 4 times 7. Do you see that?
Yes, ma'am.
Does this make sense now why I did that?
Yes, ma'am.
And so now I've included face number 5 and face number 8 in that one calculation.
Yes, ma'am. Thank you.
Pleasure. Okay, let's move on. We have 2 to go before our brain break. Hopefully, actually, we'll probably just do this one and then go into our brain break. Let us look at this. Now, something that I want you guys to be super duper aware of is if we are calculating surface area, you have to know whether the shape is open or closed. Because think about surface area. It's literally measuring the area of the faces of all of our, or the faces on all of our objects. So if one of my faces is missing, for example, if I have a tissue box that doesn't have one of my faces because it's open for the tissues, can I really include the area of that face in my surface area? No, I cannot. So you have to be super careful when you're doing these surface area questions. If they said that this cylinder was closed on the top, then what you would do is think about what you normally do for surface area. You would calculate the area here, area of your semicircle, area of this rectangle that's making the curved part, but there would also be a rectangle closing the top of this. Okay, I don't know if you guys have seen those like half barrel braais. Like literally, we can literally make it a braai now. Think about the grid that goes on top of this braai. Okay, that would have been covering the top of this barrel. So we have to include the area of that face in our surface area. Did that make sense for everyone?
Yes, ma'am.
Good. Thank you for answering Liaho and Shady and Itandile, and I saw Imile's thumbs up as well. I think so. I'm actually so I don't know what the word is, but I just think it's so funny that I just drew a braai on here. Anyways. Moving on. Okay. Now that we've got that out of the way, let's calculate. How do I calculate the area of half of a circle? If this is face number 1, I want to calculate the area of half of a circle. It looks like a pig. I want to know, how do we calculate the area of half of a circle? Yes, Imihle.
Ma'am, you have to say pi r squared and then like divided by 2. Well, first calculate the area of a full circle and then divide by 2.
So what is the area of a full circle?
The area of a full circle is pi r squared, ma'am.
Pi r squared, 100%. And then we would divide it by 2. So to calculate this, I would literally use this formula and calculate my semicircle. Thank you very much, Imihle, for that formula.
Thank you, ma'am.
Now, though, what I want you guys to see is you could go surface area. You could go and say surface area equals pi r squared divided by 2. Plus, if this is face number 2, you could go again pi r squared divided by 2. But if I've actually got 2 halves make a whole, right? So we don't actually have to divide it by 2. We could just keep it as pi r squared. But just know in our mind that it's because there are 2 half circles. Okay, so that's a shorter method. I'm not going to do that method because I want you guys to understand that we're calculating the area of each face individually and then adding up. Then over here we have this rectangle. So the one length of my rectangle is going to be the circumference of my circle, which is going to be 2 pi r. But it's not the full circumference, it's actually half of the circumference. So half of the circumference is actually, the 2's are going to cancel, and it's just going to be pi r. And then, so this would be pi r, and this would be the other length of the rectangle, which is 10. So this I'm actually just gonna do this quick. I'm just gonna say this is gonna be my height. So this is called my height since I'm using all variables at the back here, or rather in this first step. And then what we have to do is now add my bride cover. Okay, we're adding our bride cover into our surface area, and what that would be is it would be that height, that h that I've just labeled, plus, not plus, but multiplied rather by the diameter of the circle. Do you guys see that this is the diameter of the circle? Okay, good. That makes sense. Now, I want you guys to know these are not formulas you have to memorize off by heart. This is just a formula I literally made up right now, just based on knowing how my formulas work and manipulating them to suit this problem specifically. So now that I've done that, I'm literally going to substitute. It's going to be pi, my radius, by the way. They've given me the length from here to here, which is my radius. And so that is going to be 3.6 squared divided by 2 plus pi 3.6 squared divided by 2 plus pi. My radius again is 3.6. My height we said was 10 plus my height was 10. And my diameter is 3.6 times 2. So that is going to give me 7.2. 7.2. Plug this into your calculators and let me know what we're getting for this entire thing. Yes, Imishle.
Ma'am, I just wanted to like make sure and clarify. So with the formula, ma'am, so does the pi RH, it comes from pi times the 3.6 times the 10, and then the HD is from the 10 times the 7.2. I mean
Yes.
yeah, okay. Thank you, ma'am.
Yes. Isanila, you said you also had a question, yes?
Ma'am, I have a question on why did we I forgot my question. Ma'am, how did we come up with pi RH plus 8D?
Okay. So I have to now go and figure out the length of this curved rectangle at the bottom of my cylinder. Are you following that, Itanile?
Yes, ma'am.
And so I want you to think about how we would be able to calculate the area of that rectangle. Do you agree it would have been length times breadth for a rectangle?
Yes, ma'am.
But now I know that this, let's call this my length. But what would be this breadth, right? Because this part over here would be the breadth. Do you agree?
Yes, ma'am.
So how do I calculate what this is going to be? This is going to be equal to the circumference of my circle. Do you see that?
Yes, ma'am.
but it's not the circumference of a full circle. It's the circumference of half of my circle. So my circumference is going to be 2 pi r multiplied by my height, which is this. Remember when we dealt with the cylinder, we said we're going to multiply it by the height of the shape. So that's why I just used this variable of h. You didn't even have to include a formula like this. You could have just said multiplied by 10. Okay. But remember, we don't have a full circle. This is the formula for the circumference of a full circle. Do you see that?
Yes, ma'am.
So I divided it by 2. And do you see when I divide by 2, my 2's cancel each other out?
Yes, ma'am.
And so what I was left with is just pi r h, or pi r times h. Are you happy with that?
Yes, ma'am.
Cool. Now that we've done that, I also needed to calculate, because we said this was a closed shape, I also needed to calculate the area of the cover that would be on the top. Are you with me here?
Yes, ma'am.
And the area of this would be the same variable that I've called h now. It would be that 10 multiplied by the diameter of my circle. Do you see that?
Yes, ma'am.
And so that's just where the HD came from.
Yes, ma'am.
Okay. I'm glad that you're following with us again, Itandile.
Ma'am, I think I know the answer.
Tell me.
225.81.
225.81. I'm not sure how correct this is. Let's check the other answers in the chat. But I'll take it as the actual answer for now. Thank you, Itandile. Okay. Tyra, you got 599.82. I'm sure that you didn't divide one of the things by 2. Just check. Yes, Umar.
Ma'am, why did you put centimeters instead of units? Square?
You're right. You are actually right. Because I didn't look. That's why. You are supposed to have it as units. Thank you, Umar. And then let's jump into a brain break. Except that it's already 20 past. So I'm going to literally take 2 minutes on this. Everybody put your answers in the chat. Nobody is talking today because our class likes to talk. We have microwave, fridge, oven, stove. One must stay. This one, I don't know the answer. Fridge. I mean, like, we could use a cooler box, you know. But also we could use a fire to cook. One must stay. I think I'm gonna keep a stove. Actually, a fridge makes sense. Oh my gosh, I don't know. I actually don't know. Fry every day. Fridge. A lot of you guys are saying fridge. I don't know. This is a really tough one. This is a really, really tough one. I think maybe the oven. Because everything else has alternatives, right? Like, you can warm your stuff on the stove. You can, or obviously if you don't have a stove, you can warm your stuff on a fire and you can cook your stuff on a fire, right? With a fridge, people used to use like ice boxes before they were fridges. So we could do that again. But the oven, how do we replicate an oven? We can't really. So I think I'm keeping the oven. Because also baking. Baking can be done in the oven. So that's that. That's it. I see the hands. I see the hands, guys. None of us are talking today, so you guys can literally talk just unmuted, but you're probably gonna talk over each other, so that's that. Coffee, tea, juice, cold drinks. Umaliako itandile imihle. Your hands are up. What are your takes?
Coffee, ma'am.
Okay,
Hey, ma'am, I'm trying to think, ma'am. It's this one I'm trying to think.
Yeah,
Tea,
first thinking.
Yeah.
Uma says tea. I also think tea. Well, actually, I don't know. I don't know.
Ma'am, I think cool drinks, ma'am. For me, cool drinks.
Right?
Because
Because I don't know. This
Yeah,
is too hard. I can't even think of this. It's too hard for my
so,
brain.
ma'am, you would like coffee over tea.
You know. Well, I don't know. That's what I'm saying, Itandile. I don't know. I don't know.
What do you drink every day, then, ma'am?
I drink different things. Some days I drink coffee. Some days I drink tea. Some days I
same, ma'am.
drink
Same,
juice.
same.
Some days I
Ma'am,
drink cold drinks. So I don't know.
ma'am, I don't like cold
Girl,
drinks.
ma'am, this
I
next one is
really
so
don't.
difficult because I love all four of these shows. And I
Same.
grew up watching these shows, man.
Like Teen Titans, Fetus and Ferb, Adventure Time,
For
SpongeBob.
all the people who are gonna hate me now, please hate now. But I hate Teen Titans.
What?
Ah,
I remember
Itandile.
you saying that, Itandile, actually.
Yeah, I also remember.
I hate it because like
Crazy.
it's just fictional characters doing nothing, and they're teenagers, but then they're all over the.
That's literally
You
what
fool
all
me.
of these cartoons are like, Itandile.
But then, ma'am, Phineas and Ferb was different because the sister never got to tell on her brothers. That's the
She would always
interesting
say,
part.
I'm gonna bust you guys, and then she never told them. Told on
She
them.
never. The mother doesn't believe her.
I also don't like Adventure
Privileges of being the youngest child, guys.
And also, ma'am, Adventure Time just disappeared. Literally,
It
I
just
I
don't
disappeared
see
out of
that.
hated.
nowhere.
I hated Adventure Time. It was so weird. Like everything that happened in that show was so weird. It was
Ma'am,
too
ma'am,
Yes,
weird.
ma'am.
Ma'am, it
ma'am, I
was
think, ma'am, I
weird,
think
but
you
then
actually
it
should
was
have put
fine.
like
Thank
regular
you,
show here.
man. So,
I think
And
I
then
should have.
SpongeBob, ma'am.
I think,
Just
ma'am, you should have put regular show in this list.
yes, ma'am.
See, but
Definitely.
regular show was also kind of weird. Regular show and Adventure Time, I like grouped together in my mind. And the one with Gumball, what is that one called?
The
Gumball in
Amazing
the
World of
Amazing
Using
Gumball.
World.
Gumball.
Yeah, those ones I grouped together. Gumball was still a little bit better, but those ones were all like super weird for me. Like really weird things used to happen.
man, I agree with you on the Adventure Time and regular show, but Gumball deserves its own recognition. No way.
Because,
I
ma'am,
did say
it's
it
like,
was better.
ma'am, because like in Gumball, like you get your inner child just kind of comes out because you see dinosaurs on the hallway, you see a robot,
Honestly,
like
No, 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 no.
Alright, so ma'am, I'm actually gonna keep SpongeBob, ma'am. Yeah, now let's get back to maths.
Yeah,
Yeah,
keep SpongeBob. He's iconic.
I actually think I would agree with you guys. I
That
stopped watching
ma'am,
SpongeBob long ago, though. Yes,
SpongeBob's laugh is just a very iconic one. It's just so nice and so
agreed.
funny to listen to.
Agreed. Okay, guys. Back to maths. We're looking at this diagram over here. First things first, it's a normal rectangular prism and it has a cylinder on top of it. So this is where it gets tricky. Do you guys agree with me that this face on the top here, it would be a normal rectangular face, except that there's a circle that doesn't count? Like this, where the cylinder is sitting on top of it, that can't count as surface area because I wouldn't actually be able to like touch it because the cylinder is sitting on top of it. Let me know, are you guys seeing that? Okay. So what we would do here is we would go and we would calculate the surface area of the rectangular prism and then we would minus the surface area of the circle. Okay? So you're going to take your surface area of your rectangular prism and you're going to minus the area of the circle. Are you guys happy with that so far? Okay, I'm seeing some thumbs ups. I'm just going to talk you guys through it. I want you guys to try and attempt it yourself. Also because there's only 5 minutes left of the lesson. So once you've done that, we've now calculated basically the surface area covered from this bottom bit. But now we still have to calculate the surface area of the circle on the top plus the surface area of my curved rectangle that goes around my cylinder. And how exactly would I do that? What is happening? Break it down how, Brim? Like into a circle and a rectangle. Yes, you can. 100%. So it is going to be pi r squared times 10. That's volume. Uma, what you just did is calculated volume. Remember, we are calculating surface area. So what we would do is we would then go and we would add pi r squared, and then we would also add the rectangle, the curved rectangle. One of its lengths would be 10. So that would be the height of my cylinder, which is 10. And then the other side of it will be equal to the circumference of the circle. And the circumference of the circle would be 2 pi r. Does this make sense, everybody? Speak now or forever hold your peace.
Ma'am,
Yes?
ma'am, why are we adding the pi r squared and the 2 pi? Wait, the 2 pi r h. Yeah, 2 pi r
Okay.
h.
So remember, initially we're still calculating surface area. So do you agree
Yes,
that
ma'am.
this circle on the top of my cylinder would form part of my surface area?
No, not. I don't really get why, ma'am.
Okay. So I have this rectangular prism and I have a cylinder on the top of it. Do you agree
Yes,
that
ma'am.
the top of my cylinder, it's something I can touch? It forms part of my surface area.
Mm-hmm.
The
Yes, I
circle at the
understand now.
bottom, though, the circle at the bottom does not. Do you see that?
Yes, ma'am.
I can't actually touch the bottom of my cylinder. So I'm not going to include
Yes.
it in my surface area. But I can touch the top of my cylinder. Do you see that?
Yes, ma'am.
Do you get now why I'm including that in the surface area?
Yes, ma'am.
Okay, so that just explains why I included pi r squared. That was the area of my circle at the top. Do you see that?
Yes, ma'am.
Then, do you agree that this curved rectangle also forms part of my surface area?
Yes, ma'am. Because you can touch it, and it's not
100%. It's not like blocked by anything. I can touch it. It's part of my surface area. So this
Yes.
10 centimeters is the height. Do you agree?
Mm-hmm.
So that's where that comes from. It's my height multiplied by the circumference of my circle. Because do you see that my rectangle is going to go all the way around my circle?
Wait. Yes, I can see. Because
Sorry, I don't know what just happened. Yes. So remember that rectangle goes all the way around your cylinder. It goes all the way around your circle. So that length of your rectangle is actually going to be equal to the circumference of the circle. Do you see that?
mm-hmm.
And that is where I got my 2 pi r from.
Okay. Thank you.
Pleasure. And that is that. So you guys can now go and calculate the surface area of your rectangular prism. So every single one of the faces. Don't forget the face at the back here, the face at the side, and the face at the bottom. Then you're going to subtract the area of your circles to take out this area. Then you're going to add the area of the top circle. Then you're going to add the area of the rectangle in your cylinder.